Welcome, everyone. If you want to talk, you can use the code stream chat right above the voice channel here.
Exactly. We'll see how many bugs we can get. Oh, yay! Drawing is good. I approve. All right, I'm going to share my screen at this point. I think I cleaned off all my very suspicious things. And by suspicious, I mean other servers, other projects that I'm writing code for.
So in this stream we have myself, two of the design leads, Nova and Gala, Checkmate the programmer, and Mystic Witch the programmer. Checkmate is going to be showing the flight system and showing how adjusting the values associated with the flight can change how certain dragons feel. If you want to make suggestions for crazy numbers, there'll probably be points where you can do that. If at any point Unreal crashes, we're going to dust off the wheel and make some people draw quick sketches. And feel free to ask a couple questions if you want. This isn't explicitly a Q&A stream, but still feel free to try and ask some stuff if you want.
And ignore what's going on my screen for now. I will explain a lot of this. I'm just doing some last minute setup stuff to make things feel right initially before I show things and explain them. And let me know when I can't start right now. I'm just kind of doing last minute setup stuff. Things I realized I forgot. Also, just to check, like if you suggest things, because I'm sharing my screen, so I can't see anything. You see exactly what I see. So someone else will have to read off suggestions to me. So that's good.
Yep, I'll be doing that.
Thank you. Just FYI to everyone, if I don't see your suggestion, that's why.
So if you don't see their suggestion, it's my fault.
Exactly, yes. I take no responsibility for any problems that arise. Ever.
I think we're ready to start when you are, Checkmate.
Okay, cool, awesome. Let's get going. So yeah, hi everyone. This is a I'm going to be showing off some, like you said, some flight stuff. Note that this is not our map. This was a random Unreal demo map, which is going to be very nice because there are trees and stuff, so I can use it to estimate how fast I'm traveling more intuitively. But it is not representative of what our map will look like. It is not. The only thing that is ours in this setup is going to be the dragon and the physics itself. So just to explain that, before you think we're showing off a completed map, because that's not the case. The reason we're doing that, of course, is we don't want to spoil unfinished pieces of the map and all of that. So just to get that out of the way. So I'm gonna actually start by clicking play here so we can see my very mediocre setup. Didn't load the first time. Let's try that again. Well, good start.
Always happens in coding.
Oh, I know what's wrong, I think. I forgot to save last time. So let's just add a, let's just place a start. There we go. Now, very good, excellent. All right, so yes, so it's working. So this is what my setup is gonna look like. We're walking around. So the Scoria is actually ours. It's using some cool graphical setups. Note that we are clipping through the ground a bunch. We just showed off a little bit of IK. This IK is currently a little broken because I'm on a dev branch, as well as the fact that I am currently not loading in some of the fancy quadruped stuff. So we are going to be floating a bit off the ground. That is intentional because that's not what I'm focused on this stream. So just don't be surprised. But the next thing I want to show off is how flight you launch right now. I am going to be fiddling with numbers, and my goal over the course of the stream is to make it feel less insane. So right now you go very, very fast. You can see my velocity on the upper left. You bounce off of things very hard. It doesn't feel good at all. At the moment, it doesn't really feel like a scoria. It just feels like, I don't know, you're a jet plane or something. And the animations are all bored because you're going extremely fast. So just to show kind of what we're going to be starting with here. This is all of our custom physics and stuff like this, so I can have various controls. Oh, the last thing I forgot to actually do, let me, I'm going to stop streaming for a second while I set this up. Forgive me. I forgot to set up my keyboard thing ahead of time because I'm dumb and I don't want to show everything that's in my downloads folder. So let me just do that really quick.
So sometimes we might have a keyboard display on the screen to show what buttons are being pressed, just in case you're curious which buttons are being used to make flight work.
Yes, exactly. And I have it all set up. I just need to run the thing. It'll just take a second. I'm using an extremely professional utility, so, you know. There we go. And so now let me make sure, okay, setup looks good. Let me start streaming again. Sorry about that. All right. Can people see my keyboard controls? I picked some defaults. The only ones I'm going to be using are WASD, Shift, Control, Alt, or not even Alt, and Z. And I have left and right mouse in case people are curious. So to show flight again now with the actual controls, here you can see I'm holding down Shift to flap, so I'm pressing space to go up. I can press W to go in the direction I'm facing. If I let go, then I can move freely. And I hit an invisible wall. Very good. Wah. All right. Right now, you just kind of fall out of the air when you hit something. Very exciting. And then I can brake, and I can hard brake by holding down Shift. And it can be hard to recover. So as you can see, flight isn't going to feel very good right now because again, that's the point of the stream. But just to show kind of what it'll look like as I mess around with controls over the course of the stream. So brake.
Do you want to explain the numbers in the left?
Yes, that's the next thing I was going to do. Thank you. So the numbers on the left, when I'm on the ground, of course, they are mostly zero. So velocity, there's always a velocity. This just shows how fast I'm moving. So when I start walking, I gain velocity. You'll notice there's a slight acceleration. It's pretty minimal. When I run, you get a little more acceleration. It decelerates quite quickly though. So velocity is true always, but you'll notice that thrust, drag, lift, flap force, these are all zero because I'm not in the air. I'm not going to, actually, since this is very relevant to this stream, let me pull up a flight diagram, plane forces diagram, because this is going to be extremely relevant to giving a sense of what I'm going to be doing over the course of this stream. You don't have to understand this completely, but very, very simply, we're going to use this excellent, extremely professional diagram here. Thrust is like how fast forward you're moving. Lift is how much you're going up. Weight, which we just use gravity, is pulling you down. I'm not going to display weight because it's constant. And then drag is how much you're being pulled backwards. So it's like how much air resistance there is. So the game itself has these numbers. So right now there's no thrust, drag, or lift because we're not in the air. When I start moving, what you'll notice is that my thrust is quite high. When I stop flapping, my thrust goes away. I'm not generating thrust, I'm just gliding. You'll notice the drag goes up and down a lot depending on my angle because the amount of drag a plane has, or in this case a dragon, depends a lot on how your wings are positioned. There's a lot of math there that I won't go into. And then lift is how much lift there is. So right now lift is extremely high. It is, you'll notice that if you look closely, it stays around 4,000 when I'm doing nothing else. And this is because gravity is around 4,000. These numbers are completely arbitrary. I don't know what 4,000 means either. But that's kind of what that is. I don't know how visible, those numbers are not going to always be super visible. They aren't always to me, but just so you know what I'm looking for there. Finally, flat force, you'll notice, is mostly zero, and then sometimes it's 3,000. Flat force is a fudge factor that simulates birds. So it turns scoria from a dragon into a bird, more or less. And so by applying flat force, when I go up, so I'm basically simulating the fact that scoria wants to go up. A bird can go up. You can apply this flat force to start going up. So when I'm not going up, even when I'm flapping, you don't get this force because I'm simulating that you'd angle the wings a bit differently. So you'll notice when I go down, of course, my lift goes down to zero because I'm diving. My velocity goes up a lot, etc., etc. So I'll talk through these numbers more as I start fiddling with them. They're going to matter a lot. I need to have them on the screen so that I can actually calculate stuff. It's very, very difficult to work out flight, kind of these basic flight systems without these detailed numbers. The last thing that's maybe kind of interesting is that W alone will generate things like flat force because it will handle pitch as well as roll and yaw. So if that was a bit technical, then that's fine. That is the most technical I'm going to be getting on this stream. So after this is basically just going to be messing with numbers and seeing how they work. And but I just wanted to explain the basics so you have some idea of what I'm working with. All this kind of standard plane forces.
A few minutes ago, Keo Dragon said, I wonder if we're going to be able to do the flight thing that larger flyers tend to do, where their flight is basically a series of dives and climbs so they can keep their speed and lift.
Yes. Okay. So actually, so this is hilarious. So this is that's a great question. The answer is yes, although I do want to clean it up a bit. So if I right now, with my current setup, which is not ideal, as I've alluded to a couple times, notably by the fact I can't recover when I start diving with my current arrangement of numbers. If I sit here, so notice that my lift is actually quite low right now. It's because my flat force is generating most of my lift. So if I, though, start kind of just moving in a direction and I let my velocity go down, what happens is my lift drops. And then I have to go down a little bit because my drag is getting too high. So you'll notice I'm essentially kind of going down and then I kind of level out. If I zoom in more, you can see this better. So I kind of go up and down like this, and my lift is not being maintained. To actually go up, I can't do it without flapping, so I need to sit here and flap. So in some sense, you're simulating exactly that. I'm moving so fast that I run out of map really fast. We'll be fixing that. But essentially, yes. The main design question we have is how much we want to automate that process, because that's just a real physical process, and it's actually it's really hard to avoid in our current setup, having that sort of up and down to maintain height. And then the question is if that's actually going to be interesting gameplay, which is something we've been discussing a lot. So that's going to be, I think, a ongoing design question, whether or not we want to maintain exactly this kind of feel where you go down and then you level out over time once you get enough speed. And that's partly what I'm going to be working out today. Hopefully that answers the question. It's a very good one, if I understood correctly.
Keo Dragon also asked, will different dragons have different dragon thrust values, aka, so will some dragons be able to fly faster or longer than others? Yes, that's the whole point of having our big number system. It makes it really easy for us to adjust how flight feels per different worm.
Yes, actually, that's a perfect transition for me to show off what I'm going to be spending most of today doing, which is we're going to be fiddling with numbers. I have a fancy spreadsheet here, which is fancy in the sense that it has all of the numbers kind of set up along the rows. Credit to our artists for making it look good as opposed to letting me have my way with it, in which case it would have all just probably been binary or something. Hi. Love you. And then, we have kind of, these are going to be all of our different numbers. These numbers are meaningless right now. These are essentially what I'm wanting to do is fill in this table, because I don't know what's going to feel good and bad. I have some rough calculations on paper, but at the end of the day, you got to experiment with it. And so what I'm going to be doing most of today is actually figuring out the thrust for different kinds of worms. So very concretely, we have this massive list of numbers. I'm not going to explain all of them. For reference, a couple of these are these kind of equations. I'm going to be referring to this a couple of times. I don't expect this to be super meaningful. These are some internal math that's going on. But there are all these equations, and then there are all these numbers. So very concretely, I have a flap acceleration, which is the same as thrust. It's basically the same thing. You can see I have some comments here. It's an acceleration, so it's measured in meters per second squared. It's your thrust while flapping, and it's higher. If it's higher, you move in the direction you're facing faster. If it's higher, you have a higher maximum speed. So very concretely, I'm going to be actually modifying these numbers. So we can actually sit here and modify flap acceleration. And the problem is I'm already going very fast, so I probably will continue to go very fast. But now I'm going even faster. Oh my God, I'm going so fast. Okay, so you can see this is what it looks like, and this is what we'll be doing is finding good numbers here instead of. But yes, so hopefully this demonstrated what you're asking, which is that you could have a very fast worm like this, and we absolutely will have different numbers for different worms. And the problem is I have no idea, is this too fast for a fast worm? Yes, this is too fast. You're going to go across the entire map in like a microsecond. But what is the right number so that you can feel like you have a heavy worm with a certain amount of flap versus a very lightweight worm with a certain amount of flap? So
could we have the content browser pulled down a little so you can see more?
yes, sorry, I know.
No worries.
Let me try again. I have not streamed much, so forgive me.
Off-Zero asked, how does the system handle cases where a U is formed when you lower the peak at the same time you raise it? Does it allow this to be done, or is there a trigger that prevents the movement from entering?
I'm trying to understand exactly the case that's being described here. So there are a couple of checks that make sure that you don't go out of bounds. They are not actually super common. The way it's usually, actually, maybe a useful thing. So let me just show again really quick. This is extremely fast flying because I want to show very high thrust because I think it's funny. I can also set it very low so you can see what that looks like. It's not a bad idea. But I will show a couple of cases where you can essentially, let me just keep this down. I don't need to see the content browser most of the time. All right, there we go. That way I don't accidentally forget again. Put this up here. All right. So if I sit here, let me. So there's not a ton of checks, but I'm not going to get distracted by this. I'm going to show off lower thrust, and then I'll finish answering the question. So if I lower the thrust quite a bit, you can see I'm taking a lot longer to build up speed. Now I still have a lot of speed because my takeoff speed is very high, and I don't have much drag. But now you can see I can't go as fast because I cut down the thrust a bunch. So just to illustrate what that might look like. This actually doesn't look that bad. Not as bad as I expected. The problem is I probably can't recover from dives very well. All right. We'll fiddle with that. That's going to be the point. But to answer your question, what about extreme cases? So because of the way these graphs are shaped, without going into it, I briefly showed the math. I'm not going to explain it. Basically you can stall is the intuitive thing. Right now, the numbers I've selected make it so you cannot have you basically avoid inflection points in the calculus sense. You can't have this like extreme cutoff where you can't recover. But I can select them so that that's not true. The easiest way to do this, so my critical lift angle basically is how hard various factors. It's a complicated number, but it roughly describes how long until we stall. And if I sit here and I increase the max wing pitch to like 40, so if I go way outside the critical value, what'll happen now, previously I could go up without problem. Sorry, it takes a couple times to load because of the textures and stuff. Okay, so now if I try and just go up, did I modify the correct one? I did not, it looks like. Ooh, I know it's wrong. I need to modify the other one as well. I forgot I have 2 checks here because this is something you usually don't want to do. There we go. You can customize this a bit more. But if I change both the target and the maximum allowed, what will happen is, as I start going up, I should hit a critical angle here, and my lift will just vanish. Yeah, so you can see the moment I stop flapping, I just kind of collapse in agony. The reason I survived at all is because my flap force was keeping me out. But if you look closely at the lift, if you look at the lift value, it'll cut off here. Yeah, it's like essentially going to 0 very quickly. And so the moment I stop flapping, it like completely collapses and it's really hard to recover. Yeah, basically impossible. I just stall. So the answer is yes, there are a bunch of extreme cases. We can explore these. And there is no check. It just happens. You probably just crash. So yeah. There are a few checks, like I said, for things that would cause you, for example, to go at maximum speed into the center of the Earth. I do try and check for those.
Andrew asked, are you planning on having outside factors affect your lift/velocity? Like if you get hit by a fireball from another dragon or something, or like high altitude wind gusts. What about fireballs coming in from different directions, getting hit from below, applying some flap strength from the front, decreasing velocity from the side, pulling you to the opposite side, etc.?
I appreciate the softball question in the sense that, like, yes, absolutely. It makes it. I'm really happy I can talk about that. Like that's exactly what this system is designed to do. So I really appreciate that because it's like, yes, that's like why we have all these forces is because now the advantage is that Scoria generates forces instead of actually moving, and so then you can add more. Like you can have a strong wind gust that blows you out of the sky. This was actually the entire motivation for designing this. Is we've been talking a lot about like, a bird is flying along and then uses thermals to go up without needing to flap. I wanted that feeling, and so I haven't tested it, but in principle, that's like the whole point of this.
Now, design-wise, I don't know if we could say for sure that we would want like every projectile attack to have potential to knock you out of the air, but we could maybe, and it would be cool.
Yeah. It's definitely I'm just happy we can do it, and then whether or not what design-wise makes sense, I think is a very reasonable question. Let's start with these.
Kyo Dragon said,
By the way.
yep. A good way to figure out reasonable flight speeds and capabilities is looking at real birds and their wings, since wing shape determines a lot for flying style. Yeah, we definitely reference animals a lot. We have multiple channels for it.
The reason I'm not going to be doing that right now, to be clear, totally agree. I'm not going to be doing that right now because because I know to actually be more honest about what I'm doing here. What I really want to do is figure out how the very made up fantasy physics of the game kind of correspond to those very real wing shapes. So I have all of these like columns representing agility, speed, endurance, and what I'm trying to do, these are very broad categories, and I'm trying to figure out, okay, what numbers in Unreal kind of work out to the same thing, because the dimensions aren't for example, gravity is 4,000, which like, yeah, I mean, it's in centimeters per second square, but it feels wrong. So yeah, really, actually, I think that's what we want to do. So that's why I'm going to be sitting here and recording, so that I'm hoping that once we have kind of baseline numbers, then we can go against real birds and be like, okay, this is roughly corresponds to this real bird sort of deal. Hopefully I'm not being too optimistic there, but yes, agreed, in short. So I'm going to be recording my starting values that I'm working with. I should actually just, and other people can feel free to talk at this point, because I'm going to be sitting here just kind of boringly go through here, and so I don't like my initial ones, but I'm going to record them all so I know what I'm working with. This is a coding stream, so, and as we all know, coding is a lot of just comparing numbers and stuff. So that's going to be my life for a bit. Let me do it this way. This is the, I guess in the same sense as an art stream, you're going to be doing a lot of sketching and looking at references and stuff. So it won't
Just
be
vibes.
Yeah, just vibes. In case it's not immediately obvious, I am. Oh yeah, I'll add this later. This is going to be important, but not now. In case it's not obvious, I'm literally just like copying and pasting numbers.
Nova, feel free to repeat what you just posted verbally, just since Checkmate's busy for a second.
Sure. Scoria, its wing shape is based off of eagles, vultures, and condors because it's a slow, long-distance flyer. Levin is based off of falcons and swifts because it's a fast, agile flyer. The Juvie dragon and Juvie wyvern are both all-rounders. Dragons based more on large bats, and wyverns a little bit more on falcons and shape. Since they're juveniles, they're more generalists, but the wyvern has a little bit more lean for speed and agility, since wyverns are just generally usually a bit better in the air than dragons. The tier 4s are really just going to depend on each individual worm, but there's trends.
Seagull worm confirmed.
I want a seagull worm. I feel like this max roll is not what I want.
I think seagull, albatross type wings would be really cool in a worm eventually.
Oh, that'd be so cool. Actually, let's try 60 for a bit.
Off-Zero asked how heavy is the algorithm?
What do you mean heavy? I guess like how computationally intensive, or how many lines of code?
Officer clarified computer resources, for example.
Oh yes, computationally very very light actually. It's all floating point math. It is, you do have to apply it across vectors, so you're doing a couple of like vector normals or whatever. But it's I think the useful estimation is it's significantly cheaper than normal ground movement. I mean, it's a lot of computation compared to most things I'm used to doing, because there's just a lot of steps involved. But it is much lighter weight than the ground we use, which is similar to how Unreal does ground movement. So it's comparable. It's less than that. It's hard for me to give a precise estimate, but yeah. There we go. All right, so the first thing I notice, to talk a little bit through my process here, so I'm done recording things, and what I'm going to be going for first here is I'm going to try for, I think because it's a scoria and it looks heavy, I'm going to try for a heavy flyer at first. So I'm going to increase the mesh size a little bit, and I want to get that feel. I want to get the feel of like maybe like a condor, you know, a big bird that it's little, you know, there's some endurance there too, but I want to get something that like you feel like it's hard to turn, it's a little hard to move, you're not very mobile. So that's going to be the first thing I'm going to work for. If I notice a value that I think works really well for another column, I might do that. But this is going to be my starting point, I think. So just to explain what I'm going to start fiddling with here. And if anyone wants, so I can talk, let me talk through the most relevant numbers, because these are going to be, I think, if people want to see extreme values for any of these, I'm happy to do them. I'm going to ignore everything above, above the air column, because I don't care about it. So I'm only going to care about flight, and I'm just going to explain like some of the numbers up here. Everything down here I'm going to fiddle with actually quite a bit, but I'm not going to explain them because they're complicated. Like I alluded to the critical lift angle. But I think some of these are worth knowing, because you can suggest, like, I want to see what happens when this gets cranked up, and we'll see if we crash. Like literally, Unreal crashes. All right, so takeoff boost is like what I'm using to be like, so I don't have the takeoff animation set up, so I'm just using this for testing. So when I press spacebar twice, I get this massive boost of forward speed, and I enter flight mode. This is very hacky. It's just meant for testing, but this is how fast you start going. Roll speed is like how quickly you kind of roll back and forth. Max roll is probably the more interesting one. It's like how far to the left and right you can lean. I've never tried putting it above 90. I assume you just flip upside down. It might crash. No idea. I haven't tried that. Max wing pitch. Basically max wing pitch is like how fast you can go up or down. I might have to adjust some other things to make this work. And these are very similar. I'm not going to explain the difference, but yeah, this is like how quickly you move up and down. Min dive pitch is a really interesting one. This is how far down you can face, which the farther down you can face, the more speed you can build up, but the harder it is to pull out of a dive. Pitch speed is like how agile you are moving up or down, which is similar to roll speed. These are just like agility up or down versus left and right. Flying look turn speed. I'm not actually. These are just. I'm not going to explain these. They're not interest. They're like how the W key works. And then dive angle is an animation, mostly an animation thing. It has some physical impact. So it's like if I set this to 0, then when you're flying straight, you'd technically be in a dive, which is probably not what I want. But it basically, I can use this to adjust how fast you enter a dive. Flap acceleration is your thrust when flapping. Flap lift is your lift when flapping. So those are the main numbers that I care about. Oh yeah, I guess I'll explain. And then air resistance is how much the air pushes against you. The reason I break it down by value is this simulates your wings are in different positions. So if you're braking, then you have a much higher air resistance because you're intentionally trying to slow down. If you're hard braking, you have very high air resistance. Similarly, you generate more or less lift depending on which mode you're in. So gliding and sprinting, yeah, you get a good amount of lift. But if you're braking, note that this is different than this flap lift for technical reasons. Braking is braking, of course, you generate less lift because your wings are curved, and then hard braking, you're intentionally trying to avoid lifting yourself. You're trying to push backwards, so you don't have much lift. And then diving, you don't have very little because your wings are pulled in. So just to talk through the values, if that was too complicated, I can summarize the important ones, but these are like what I'm going to be working with. And if you want to see, this is where suggestions or things you want to see break will come in. And I'm happy to explain any of them again if there are questions about them. Okay.
A question
That
from
was
a
a lot
few
of
minutes
talking.
ago from Nerdy Nobody is concerning math and all that kind of stuff. How generally would mid-air collision work, both with enemy projectiles or things like trees and such? Secondly, will there be weather that can affect flying, such as giving lift or winds blowing certain ways to aid or hinder flying attached to those points of thermal lift spots? So for the second question, yes, we want like an entire wind system actually. That will be impacted by various things, and there will be thermal updrafts in certain locations, hopefully. But yeah, for the first question, Checkmate can answer about mid-air collision.
Yeah, mid-air collision is so right now it's the dumbest possible thing. As I mentioned, you just kind of fall out of the air. You hit anything, you're done. You're done. You're no longer flying. This is of course a bit silly. I think there are two answers to this question though. The first is networking and like how will that work over the network? So when someone else collides with something, will that propagate properly? And the second part of the question is like in-game design, what will happen? I can't really answer the second part because I don't know offhand exactly what we want collisions to do. It's complicated. I know it depends on like where you get hit is one of the big notable things. From a networking perspective, from a technical perspective, essentially, yes, this entire system is deterministic. So using some networking stuff, mid-air collisions should work on both ends without an issue. And well, as much issue as there is with any kind of collision system. So it's very similar to that. And there's going to be some effect when you collide with things. And maybe from a design perspective, someone like of the leads or Neve could talk a bit more about like what you would want to see the dragon do, depending on where they're hit. Like if it's in the wing, if it's in the body, all of that sort of stuff. Or like colliding with another dragon entirely.
Right now, it's dependent on the angle that you hit something and the velocity that you hit it. So maybe if you just skim the side of something, you would be pushed a little bit away from the wall or whatever, and maybe you lose a little bit of velocity and height. If you crash head on, then you're going to really feel it in comparison. Right now, we have it split into 3 different kinds of collisions from a design perspective, anyways, not actually from implementation, of course. Where it's just a skim. I forgot what I called it, like a thwack or something, where you like smack up against something, but you don't completely lose all your velocity or anything, and then a head-on collision.
So while you're talking, I realized I forgot to make my UI bigger, so hopefully it's easier to read now. I realized that everything I said might have been useless if you can't read the numbers.
I've been able to read them fine. Kyo Dragon asked, are we also discussing how landing works? Because I just realized landing would probably be more annoying to work out than taking off.
Well, I mean, I can show you how landing works right now with whatever values I happen to have in here. The answer is it is the once again debugging mode. It's quite hilarious looking. Ow! You just kind of stop. I think if I can get the angle right, I can launch myself off the ground though, which is kind of fun. Oh, lame. Sorry, I adjusted the roll too much. It looks like very. So right now it's pretty simplistic, I would say, because there we go. I got it. That was a good launch. Very good. Wow. Yeah. Excellent. Oh, I know why that's going on. Anyway, so but in the future, so one of the big things that I think is kind of interesting, if I get the numbers right, then actually landing feels pretty good by default. I've gotten there a couple of times with a couple of setups, where you can kind of hard break into it. And right now, I cut down the numbers too much, so like I'm hard breaking super hard, and then I just kind of land. But basically, landing, a lot of the focus from my perspective on the technical side is going to be making it feel like, depending on this, like you want to kind of slow down and then have this like good incoming feel, so you don't have this massive amount of forward velocity when landing, ideally. And then there's some penalty if you're moving super fast, which maybe you can talk more about the design perspective in terms of damage and stuff like that. But from a technical perspective, that's more of what it's going to be. It's like getting the right feel for this flap and stuff, which is what I'm doing right now. Terrible at the moment. Yeah, I don't know. Oh, I guess I shouldn't change that. Yeah, I don't know exactly.
You probably don't want to change that.
Yeah, I think those are right. What is the plan for like taking damage on landing? I'm actually not. I had a mental model of like based on velocity, but it might be more complicated than that. I'm forgetting.
Yeah, pretty much based on velocity.
Cool. I guess I don't want to change this either. I feel like I want to change this.
Past checkmate wants to fight you.
Oh, violence.
Yeah, so much.
I guess it would also depend on velocity, because I feel like the damage you take from flying really fast into the ground head first would be a little different from flying really fast and like landing mostly on your feet.
Mm-hmm. Makes sense.
Off-Zero asked, in order to enter the fly state, is it necessary to activate it manually, pressing some keys, or is it automatic?
Right now, it is manually pressing some keys. But that may not. I think actually, yeah. Do you want to? Nova would be the one to talk to explain current control schemes. I think like how do you want to enter flying? Not how it works right now, but ideally, what are we working for? But I have a mental model, but you can answer more correctly than I can. I think.
Let me open the control map.
Sounds good. We've also been discussing like the right feel for this a bit too, so it's a little in flux, I think.
If I can find it. Here we are. Oh, let's not ruin my own graph. Right, I wrote down hold F while sprinting to perform a running takeoff. After X amount of seconds per species, you automatically take off.
That makes sense. So instead of pressing space.
Yeah, we have discussed this a little bit, because we want to make sure that it isn't too confusing or anything to take off. But we also want to make sure that it's balanceable, because we don't want people to be able to take off immediately. Flight is so powerful. There's also the possibility of some species being able to take off directly from the ground. It would be pretty rare though, and that would also take a little bit of time in order to make sure it's balanced. Or take off directly from the ground. I mean, like take off while you're standing in place.
I was about to say.
So I made Scoria quite a bit bigger because I want to go for that very Condor-esque feel, and part of that is like being very big relative to trees. The other thing I'm messing around with is essentially increasing your lift so that you need less speed to actually stay in the air. And I'm trying to find the right balance point for that. The advantage right now, like I think it's kind of close. The problem is I feel like my drag is a bit low, and so I can still build up like way too much speed if I'm not careful. It's getting closer though. There is a little bit of wobble, as you'll notice. I'm gonna basically ignore that for this stream. That's I just need to do some more math. It's not going to be terribly interesting, but that is something I'm aware of. But just want to make sure. Okay, yeah. So the problem is that my drag. You'll notice right now when I'm trying to like make it feel condory, the problem is that I'm adjusting too much. So my drag is getting very high very fast, which isn't quite what I want. But I also want to make sure I'm not going too fast. So what I think I need to do to talk through a little bit behind my thinking here is that I think I want to decrease my drag because, it's a very heavy flyer, like a condor, their wings are designed so they don't have a ton of drag once they're like gliding. So I want to keep my drag very low, I think. But I want to make it so there's a lot of drag when doing anything else, or when you move too far away from the optimal drag. So what I'm going to be looking at is if I can bump down the air resistance while gliding and sprinting. I'm going to try just making it like very small relatively. I'm going to ignore these for now. Bump them down. And just see like 1/10 if that's getting the feeling I want of drag. There's a lot of just vibes. And once I'm satisfied, I'll record it, but obviously I'm not satisfied yet. All right. So my velocity is a bit high, so that's the first thing I notice. What happens if so what I'm trying to do right now is, so I lowered the flap force quite a bit to make myself a much weaker climber. So it takes me a long time to kind of get to where I want to go. What I'm noticing is that my lift it's still wiggling a bit, but it's a lot more stable. So you can see I'm still going down as I go, which I probably want to correct a tiny bit. And that could just be a matter of doing some adjustments on the calculation. But yeah, this is getting closer to what I want. As you can see, I have fairly low drag here. And when I turn, my lift goes down a lot because I'm turning, of course. But my drag stays low, which is probably what I want for a big heavy flyer like this. So if I make small adjustments while turning, I can keep my lift up and I can kind of rotate around. I still notice that I'm going a bit fast though, which is probably not ideal. So I want to try and keep gravity the same because it feels pretty good, like when jumping. And 4,000 is like roughly the number I've been using. It's like fine. But then try and get that velocity down. Right now it's like 4,000, which it's a bit high, which probably means I need a higher lift and lower thrust. And yeah.
Off-Zero asked, is there any variable that controls the fall to the ground to avoid the clipping that corrects the dragon's position when it plummets to the ground?
Oh, like making it so you don't do this amazing thing where and you like are inside the ground and all this, or is this referring to the when you're diving it's impossible to recover from? Oh man, I'm stuck in the trees. I'm not entirely sure which interaction. So right now it's actually that's probably worth checking. How well can I recover from a dive with this setup? I think you shouldn't be able to recover that well. Let's see. Okay, yeah, high lift means you can recover pretty well. That's good to know. Makes sense. The variable that does control the diving clipping stuff is like this pitch logic. But actually, when you hit the ground, essentially, I consider like most of the hitting the ground to be broken right now because I'm on this weird IK branch that's busted. So any interaction with the ground that you're seeing is gonna be changed. And there's more logic there. I'm just focusing on the flight for today. Just to clarify that.
Off-Zero, feel free to elaborate if that didn't answer your question, but in the
Yeah,
meantime,
sorry, I was a little rambling.
they also asked, how does the speed you had when flying affect when you're about to land on a plane? Does it stop immediately or does it continue for a few more seconds?
So I hack in. So currently I hack in that it stops immediately. Totally, and that's because of some of the numbers I picked up here. Certainly, the intention is that you kind of have this running off, and if you're going too fast, you'll fall or ragdoll or something like this. I can even show you right now. It does maintain it. It's just a little janky because of how I set up friction at the moment. It's very, very high friction. So when I land on the ground, I should almost, yeah. So I maintain it very, very briefly, but that's because friction is like extremely high. We're basically landing on like rubber, and we're like our feet are made of glue. It's very, very, or whatever. It's very, 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 very high friction. But you can even see there's a little bit of maintaining it. So lowering the friction will make that feel better.
Off-Zero elaborated for the other question, so to speak, a sub-process that prevents you from completely falling into a tailspin.
Yes. So yes, the answer is that there isn't a single variable. It's the interaction between a few variables. It's all related to this diving nonsense. And the reason for that is that you can calculate your recovery rate by working out some of these. So one of the things I'm going to be doing that isn't shown because I haven't done it yet is you can actually calculate all of that from like these existing numbers. So one problem that we had was that let's say you have both ground, like the maximum speed you can move on the ground, and you have friction, and you have acceleration. If you have all three of these, like you can calculate one from the other two, and so this is what's called an over constrained system. So one of them gets ignored, and it can be really tricky to work out which one's being ignored. So I just got rid of one of the three numbers, and it's the same here. The amount that you are falling can be calculated, or the amount of recovery that you have is based off of air resistance, lift, and dive pitch. And same with tailspin and stalling. So, and critical lift. There are a few different numbers, so you have to sit here and fiddle with them to find the right arrangement. One of the things I'm planning to do is make it so we can just calculate directly, so you can at least see what you should expect. But there's not a variable controlling that as a result. And that's true for a bunch of stuff, which I think is kind of cool. I think it's kind of fun that I can, changing one thing has this kind of exploding effect on the result. Yeah, what I'm looking for here, so when I was messing around with it just now, show people again, I'm curious, so I'm still moving a little too fast. I upped the lift, so right now I am able to kind of maintain, I'm wobbling a little bit less, and I'm losing very little speed here. Like you can notice, even when I turn, my velocity stays quite high. And my velocity is going up and down a little bit, but it's roughly back and forth with lift. So, once I fiddle with the numbers, I'll be very stable here. So I feel like this is kind of around the lift that I want. If I don't stall, oops. Check those numbers really quick. But the problem is that I'm still moving, I think, way too fast. I think it's closer to what I want. I feel like this is getting closer to like that very heavy, difficult to maneuver feel. I also need to make it so you can turn less fast. But it's not. Yeah, I think the stalling is, I think, an indication of a problem with how much I feel like I'm overestimating the drag still, even with my dramatic cut down. And I think this means I need to change the thing I'm not supposed to change. We'll see.
You probably don't want to change this.
I probably don't want to change this. I think this is exactly what I want to change. It's like
Brigade asked, how did you set up the controls?
So well, other people can certainly talk to the design of the control scheme. In my case, it's a pretty. I'll just very briefly show the controls. There's some internal C++ logic, but basically we use wherever it is inputs. We use this stuff. These extended control scheme. It's a modern Unreal solution for controls. There's some input mapping. Right now, they're all just fixed. I just defined them. At some point, we'll have a menu where you can customize your control scheme. And one thing that I am working on is making sure that the controls are kept separate so that we have more control over what controls you have. One tricky thing there that I'm struggling with is like switching controls from like if you're on the ground versus flying, like switching over naturally. It doesn't feel quite right. So that's something I'm still working on. That's the basic setup. Hopefully that made some sense.
Feel free to clarify, Brigade, if you want a different answer. Also, you can see on the screen which buttons we're pressing at any time,
Yes.
so you can get an idea with how it literally controls there. Keo Dragon asked, how does stall recovery work, or is there no stall recovery yet?
There is practically no stall recovery, as you probably noticed by me flailing around and crashing into the ground. If you stall enough, I do allow you to essentially just reapply your takeoff boost, so you can just launch yourself forward again. This is certainly a buggy thing. I think once again, I'll refer to the leads or which the other programmer on kind of what we might want there, and in terms of like how to make that feel less bad, especially with like stamina and stuff, making sure like stalling interacts well. You might not have an answer, but just to throw a question to you all. Throw the question again. Since from a technical side, basically it doesn't work at all, but I think the design side is more interesting since that's where we're going. There's a lot of things like that where I'm, still adding stuff. We're still adding stuff.
Does anyone want to answer how we want stall recovery to work?
I think that's a question for the leads.
Okay, yeah, fair enough.
I think Gala crashed again, so Nova, it's up to you.
Oh,
Save us,
no.
Nova. Save us.
Poor Gala. Let me think about that one. But it might take me a little bit because I'm trying to figure out what aspect of stall recovery or.
It's worth noting too, we might not want stalls in the like normal sense, but I think maybe one way to look at it is like if you get knocked out of the sky by a projectile, it would be a similar effect. But like if you have no velocity and you are falling, right now technically you enter falling mode. And
I could probably talk about
our rock. Go ahead, yeah.
The transition to fall break, because that's supposed to be the intention right now for when you're trying to purposefully land as well, since you can hard break, but once you get slow enough, you should be able to transition to that fall state. If you're braking, it should go directly to the fall break, which is basically like a little parachute, slowing your descent. You have a little bit of control. You can also tuck in your wings and just crash to the ground if you want, that sort of thing. So that'd probably be our answer to stalling then, huh?
Yeah, I feel like that's the idea is like you kind of ragdoll for a bit until you have some kind of recovery thing after some amount of time, and then at that point you can enter fall break. Yeah, totally.
Yeah, and then once you're in that fall break state, you can speed up again. You can start flapping your wings to get back into the flight state.
Yes. So right now the way it works is you just, if you're going down, you are in a dive. It doesn't matter where you intended to be in a dive, which is, I have these like 5 values here. I need to either add a 6th or mess around with one of these other ones so that you can like stop yourself from moving. Right now, once you're in a dive, you can't do anything. You can't stop. Which is quite funny, but doesn't really match gameplay.
Brigade asked, do you change the rotation of the worm with your control rotation?
Like with the direction. Oh, yes, yes. So when I walk left and right, I use A and D. And actually, the way it works is I walk, it's relative to the camera. And it's a little different right now for flying. But the way it works with flying is if I want to rotate, I just press D. It doesn't matter where the camera is. Or,
I
sorry,
think
if I
Brigade was
select-
asking more dev side, like rotating the
Oh,
character
I
or
see.
whatever.
Yes, you do not actually rotate the. Okay, so it's complicated. You don't so from a technical perspective, you do not rotate the capsule. The reason I don't want to do that is that I want the rotation physics. I want more control of the rotation physics. So because I don't want to just blindly enable physics, I might end up changing that. I want to keep them separate, basically. So rotation technically is an internal variable, and then the mesh gets drawn to rotation at the moment. So it's a physical variable that's kept separate from the capsule physics at the moment. Again, this might be changed depending on parenting setup, but this since I want to keep collisions very simple for testing and debugging purposes at the moment, that's how it's done. And it's one more technical detail that might be interesting is when I'm rotating here, I'm never actually directly changing rotation. Like none of my key inputs actually change my rotation as I'm flying around. So right now, of course, I'm moving straight, but I'm pressing no keys. When I start pressing D, I don't actually change my rotation. What I'm doing is I'm literally I'm changing my roll, which is a little different. So I'm not I'm not changing the direction I'm looking, but I am changing the roll or the wing angle relative to the ground. And because lift is, if you recall, let's see, I should probably not tab out. Oh no, it didn't break. Good. If we looked at the plane diagram again, I just think this is neat. This is an irrelevant detail, I think, but for most people, it's kind of cool. If you look at the plane diagram, and look at this one. Lift is up. This one actually shows it better. So lift is up. So if you start rolling, lift actually goes right or left. And because it then goes right, you actually start your entire body of your plane starts turning to the right. Kind of cool. That's actually how it works in TLS right now. I think that's neat. Anyway, physical details. I was just very excited when that actually worked. I didn't expect it to work as well as it does. So the thing I'm noticing right now, so I'm watching the drag, and the drag feels about right, but I'm losing velocity really hard when I turn. And that's of course because I'm relying really heavily on lift right now. You can see as I go here, my lift stays high, but my vertical lift goes low. And then when I pull out, or if I turn too long or too sharply, then I can't, it's hard to recover. And that's partly because just how diving works. Probably want a higher dive angle is what I'm feeling. And then I also feel like lift is about right, but I feel like maybe okay, the angle drag correction actually helped a lot. I'm glad I changed that thing I'm never supposed to change. But the I still just feel wrong. And you can see I fall out too quickly. My lift goes to 0. Let me see if I can work out exactly when that's happening. I feel like it's because of the way the dive angle works though. Yeah. So the technical problem, actually, I might be able to fix it in a more boring way. The technical problem is that the angle of the wing is too high because I start losing elevation and then I enter a dive. Essentially, I'm stalling. This is technically what's going on. So let's try changing this. Right. Try changing. Let's try bumping this down. Yeah, that might be right. So this wing pitch controls if you can stall or not. If it's greater than your lift angle, you can stall. If it's less than, you can still stall, but it's less likely. Let's try that.
Kyo Dragon, I don't know if you actually want a detailed answer for that right now or not, but they
And
They put
I
a-
will re-emphasize, if these numbers mean nothing to you and my mutterings mean very little, that is completely fine. I have not explained them in enough detail, and that's to avoid boring people with long math explanations. Okay, there we go. Okay, so now because I changed those, the turn, I'm no longer stalling, which is good. I am still feeling a little bit wobbly, but this might just be that I need to fiddle with it. This is actually, I think, getting closer to this heavy feel I wanted. My velocity is still very high, which I don't like. I do feel like the roll angle is good though. It feels very slow to roll, which is something I'm looking for. I don't love the wobbliness. And I am losing a lot of elevation when my lift falls, which means I probably want to cut down the roll even more is actually what I want to do.
Kyo Dragon, I don't know if you actually want a detailed answer on that right now, but they posted a plane diagram in chat and said, just gonna put this diagram in because I'm wondering how roll, pitch, and yaw will work.
Okay, yeah, fair enough. Okay, so I've been talking about roll, pitch, and yaw a lot, kind of infrequently. So I'm going to guess that you're looking at the plane roll diagram. This one. I guess I could actually I could just go to chat, but I think I know. I'm guessing it's like probably this one. Okay, awesome. So similar enough, I can work with this. Omega is the thing. So roll, yaw, and pitch. So the really okay. Again, I'm going to get into technical details. I apologize to those who find this who are lost in the math. I think it's really, really cool though, so I'll explain it a little bit. Every piece, so roll, pitch, and yaw are all being calculated by the forces that we're applying. So roll, pitch, and yaw are mostly not player controlled directly. Pitch is probably the closest to being player controlled, as is roll. It's like kind of. So from a technical perspective, when I press D, what I'm actually doing is adjusting my roll, more or less directly. Like I said, I'm lying a little bit. When I press space, I'm not actually adjusting my pitch. And that's where things get more complicated. What I'm doing is I'm adjusting the pitch of the wings themselves. This doesn't get animated because I would go insane trying to like make this match the animation. And it roughly, like, it feels pretty good when you play it to not actually see it because they're pretty close to what their wings actually are anyway. So when I press D, for example, I'm actually changing the roll directly. And then when I press control right here, what's going to happen is that I'm going to start going down. And this is not because I'm changing the pitch of the dragon. I'm changing the pitch of the wings themselves. Again, technical detail, it doesn't matter much for gameplay. When I press space, the wings are going to go up in pitch. Now, because I'm not flapping, I don't actually go up. Of course, you can't just... Even though I'm trying to push my wings up right now, I'm trying really hard. All that's happening is I'm expending my energy, and I'm like, my drag goes up, and my lift stays about the same. So this lets me stabilize really hard. But so you'll see I now am very, very stable, but I can't actually go up. So pressing spacebar, it'll go up for a little bit if you have conserved momentum, but otherwise it does nothing. Because again, I don't have, I'm not getting any thrust, so I can't go up. It's not how physics works. So basically that's how pitch and roll work. Roll you control directly, pitch, well, kind of directly, and then pitch you control the wings, which then maneuver your character. Now, what about the last one? What about yaw? I haven't talked about that. Well, that's actually just so yaw right now is just how the mesh is drawn. If you think about a plane or a bird very carefully, then it doesn't make a lot of sense to actually change your yaw directly because you don't have the muscles except in your neck to kind of rotate your body around the opposite of the gravity plane. Like if we look at this, like yaw is something like you can't rotate this way directly because you're flying forward. You can't just start flying another way. You could by having a engine on the side, for example. So, and this kind of works in birds where you can kind of you can flap one wing and then you can kind of push yourself. That's pretty inefficient though. So usually what you do, and the way it works in TLS, is you actually just take the roll calculation, like the force, this weird angle thing that's now sticking out to the left because you're rolling, and then because that force is pushing you to the left, you can then just draw your mesh or have your object follow, like its nose follows the actual direction it's going. So the yaw is calculated from the roll. In some sense, that's the whole magic of this system. Sorry for the very long answer. Hopefully that made some sense. I get very excited about this. And I appreciate the question. Sorry. I'm going to go back to playing around with this. I think it's close.
Of Zerest, in the final map, will all dragons be able to enter all areas or not? Because looking at the system, depending on the configuration, some dragons in flight will be able to do things others cannot, which can be a problem in my opinion. I'm not entirely sure of the scope of your question, but I mean, in the map, there will be some spots that are too small for other worms to fit, but as for like traversing the map, there are no climate restrictions or anything like that, so any flying worm should theoretically be able to reach any other flying worm area as long as they can fit.
There should be areas that like wyverns and dragons can reach that would be harder for, say, a drake. But that just in terms of flying areas, it should just be fully acceptable for all flyers. Hopefully, everything's still up in the air as the map has not been finished yet.
Up in the air. I'm dying.
That one wasn't even intentional.
In terms of maneuverability, I'd like to add on to that. Some worms will naturally be able to, for instance, maneuver between trees, or if there's like a narrow ravine, for instance, just that sort of structure. Some will naturally be able to go through there easier than others. But as others have said, there's nothing intended to gate other worms from accessing different biomes or whatnot. Just different parts of the terrain that each can use to their own advantage.
Notably, we do want to make it so that every Drake so far, I mean, maybe there'll be exceptions, but every Drake so far has some sort of climbing ability, even if they're bad at it. So they can access those areas that flying dragons can, even if it's not as easily.
Checkmate, Andrew appreciates how excited you are.
Thank you. I'm sorry. I've been learning all this stuff. I'm learning a ton of fluid dynamics the last few months, and I think it's really cool. My friends tried to convince me to give like a technical talk at our lunch, and I was like, nah, I'm not that much of an expert. A physicist would do a much better job actually explaining it. I just think it's neat. I'm like an enthusiast. But thank you. I very much appreciate it.
I dabble in physics.
Yeah, exactly.
Cass said, forgive me if this has been asked previously. During flight, especially powered flight, will dragons stall out if they angle too steeply in an upwards climb? Yeah, we've shown that a couple times. There is stalling.
I can show it again really quick just so you can see, because I think it is kind of funny. I intentionally limit it though, to make it difficult to do. I'll just fix those later. All right, so here's what it looks like stalling. You can prevent stalling by flapping, kind of. Let's see if I lowered it enough. All right, so if I go up a bunch here, yeah, there we go. There's a stall. Bam. The reason you tilt down instead of staying tilted up is because of the way I calculate the mesh, but really what's happening, you can see if I lift it 0, I can only recover by spamming the spacebar. So that is what stalling looks like. This is actually a much better demo than I showed earlier.
And our general stance right now is it shouldn't be super easy to stall.
Yeah, so that's why I'm keeping these numbers really low. This is an intentional decision because, especially with like a big condor or something, it feels really bad to just like adjust upwards a little bit and then suddenly you're like plummeting to the ground. So basically my mental model is that a dragon who flies all day probably knows how much up it can go without stalling, and so I'm just kind of saying the player, like, it won't accept those commands. But that being said, pulling out of a dive especially, you can totally stall. Is like the main place I generally encounter it myself. See if I can do it today. Probably not. I'm messing with numbers too much. Oh my god, you're such a bad climber. Scoria, why? Scoria. Oh my god. Okay.
Scoria will remember this.
Oh man. Okay, I'm starting to get closer. I feel like you can see relative to the trees. This is why I wanted a tree map so bad. I'm moving way too fast still, but we're getting there. Getting there. These turns feel really good, really heavy. Oh, the drag is. I feel like the drag's maybe a little bit low. Get this elegant glide though. So what I've been adjusting for those interested is I've been making it so the roll is less extreme, so that you don't dive as quickly when rolling. You still do, which makes some sense, and you can't just, unless you flap, you can't just kind of turn forever. I actually think it feels pretty good. But so you're not super agile, so it's like pretty hard to turn. And right now it's hard to climb. I think it's a little too hard. I need to adjust that. I lowered the thrust a lot, so like when you flap, you don't go as fast. And I increased lift a good amount. So basically, it takes a lot of effort to kind of get off the ground is what I'm going for. But once you're in the air, like you can sit here and glide for a very long time. You will notice that this is, I think, is a very cool consequence. So right now, I'm just kind of gliding along, and you might think I'm going flat, but I'm actually not. So I should have put my angle on the screen. That would have been super nice. But I'm actually going slightly down relative to the horizon line. I'd like to get that a little bit better. But basically, this is kind of an accidental consequence. Well, it's somewhat intentional, but it's a very cool consequence of this system where there's this angle of perfect gliding where your lift is roughly equal to gravity. You can see I'm about there. You see my lift is about 4,000. And when you're there, you can just kind of glide along while spending zero effort, basically. The problem is that you're slowly going down. So you can't actually do this forever. So you need to find a thermal to push you up to give you lift, or you need to flap. So that's the feel I want to go for. The main problem is that I'm moving still too fast, as you can see. So like, if there's a prey down there, like I'm going to be flying over a Mach 1 or whatever. It's like, using no energy and then just, bam, that's probably a bit much. So hopefully that illustrates what I'm kind of looking for here. The drag, what I'm noticing is that drag is a little too low, I think, for this kind of gliding thing. I want that to be more like, drag is like how much speed you're losing over time, more or less. So I would like that to be closer to, I feel like around 200 or 300 at this point is what I'm looking for. So that I have to go at a slightly lower angle to maintain lift, and I'm like losing speed faster. The other, so my velocity is stable, of course, because I'm just going down a little bit to compensate. If I go up, I can't go up, right? Of course.
Checkmate, it seems Nova has sketched a diagram with a worm. Do you mind opening that?
Oh, yes. That sounds exciting. Oh my god, yes. Oh, that's amazing. Nova, you're the best.
That seems correct.
Yes, that's correct. That's
Open it
this
in your
is
browser
exactly
so it's
what I was
bigger.
describing. Yes. And the one. Oh yeah. Okay. Oh, this is super cool. That's amazing. I can't draw, so this is like magic to me. The one thing. So Yaw is completely correct, and importantly, like you can actually see. I think that except for the tail, which lets you do this a little bit, you really can't just kind of twist. Like that's not how it works. Which I think this diagram illustrates really well. So that's this is exactly right. The one that you could add if you want is thrust, but the word I keep using, which is going forward. So like the head is like facing the head, and then drag is like air resistance. But this is perfect. I love it. This makes me so happy. Thank you. Yeah, art is magic. I agree with this. Also, what happened while I was gone? Where am I? Who knows? Exciting.
Keodragon asked, will water
Yeah,
takeoffs
there's
eventually be
the-
possible for some species? It's probably a question more for the leads.
I would like that.
Cool. Technically, there's no reason no, but I think that's like more of it's more of like an animation thing. From my perspective, totally.
We already have different animations for whether you're swimming at the surface of the water or below the water. So there would already be there would need to be a detection for that. So as long as you're floating at the surface of the water and you're an eligible species, you could just have flight able to be done in that case. Yeah.
By the way, have there been any ideas for ridiculous values that I should pick? I know I know even after slating them all, there's a lot of numbers. It's kind of intimidating right now, even for me. Like I'm like, oh man, what does all this do again? But if anyone wants to see me mess with any of these, I'm more than happy to. Just to reiterate that.
Everything to 10,000.
Andrew says no friction.
No friction. All right. No air resistance. Thank God to do that. All right, let's do it.
And then Nerdy Nobody said 10,000 lift, go to space.
Excellent. All right. So no air resistance, I expect will look pretty similar because Scoria is a pretty efficient flyer. The main thing is, yeah, and I can't get infinite velocity going up, but I think if I go straight, I should be, yeah, I can eventually get infinite velocity, I think. Now, gravity actually does a pretty good job of pulling me down. Very good, very good. Huh. Excellent. Okay, so no air resistance, handled. Oh, I know why, actually. I should make it actually no air resistance. This is going to be better. Because then this should be 0, and that's fine. Let's try that. I forgot. I still have like a baseline that you can't go faster than this number. And then I need to that's making it not really no air resistance, which that's no fun. 50,000. That's probably good enough. Right. 5 million. All right. Let's see if I. Okay, so velocity is not going super high yet because gravity. Now if I go straight, I have too many corrections. I can't go. Oh, I just need to increase my thrust. This will work. I want to see like actually no air resistance. I have too many safety factors in here. This is no fun. Then I will increase lift super hard because that one is hilarious.
Be too careful, checkmate. You need to
we'll
be more reckless.
Here we go. Infinite velocity. Yeah, baby. Until you hit the wall. Yeah. Very good. No air resistance. All right. Let's reset these. I should have recorded them before I deleted them. It's fine. I know roughly what they were. 50. There's like 700 or something. It doesn't matter too much. These were. I have a pretty wide range here that I can still use. All right. This was like 100 or something. This was 50. This was 20. This was 100. All right, excellent. This was reasonable. Yes, but I did want to try the infinite lift. Okay, I'm actually going to record these really quick because I think these numbers are really close, and then I'll do infinite lift. They're hard to recover if I don't record them.
Don't forget that you changed the baseline drag coefficient as well.
I did, yes. I'm not going to be changing that again, though, so I'll leave it as is. I just want to record the stuff and change anything that I actually am worried about. And then, oh no, formatting. No, I'm too lazy. Let's just do this. Disaster. All right, there you go. That's what I picked.
And then lift of 10,000.
Yes, that's the plan. All right, excellent. I was just double checking, and then I had acceleration lower. I'm actually going to put that.
In the meantime, Cass said earlier, it's a bit of a pet peeve of mine to see live animals stalling out during powered flight when the animal's flapping, because it's not something you tend to see in real life unless the animal stopped flapping. Yeah, we don't really want it to be like you stall and then you have to plummet to the ground. Then there's nothing you can do about it.
You cannot stall while flapping, mostly. I say mostly because if you're in a dive, you can't flap properly. But yes, that is one trick of the trade. But you can if you get rid of all my safety values. But yes, I agree with this pet peeve. It's very silly. All right, so this is 10,000 lift, which I feel like is insufficient. I feel like I want more lift. which is fair. It is just an arbitrary number. And you might be like, wait, why is my lift only going up to 3,000? The reason for that is essentially that you can see it's like going insane right now, which is fantastic. And I will stall eventually, I think. This is because my pitch isn't that high. Oh,
Animation.
Flapping in slow motion.
Scoria does its best. So, really high lift. Yeah, you need to set a few other things. I did just want to show what that looked like though, because I do think it's interesting. You can see it's trying so hard, but what we need to do is we need to bump this up as well. The other kind of lift. There's two kinds of lift, and it's complicated. And then we also need to lower the air resistance. The problem is if we have too high of air resistance, you can't compensate with lift. You're kind of flapping, and you become really fast, and then you're flying against the wind. So yeah, there we go. That's what we're talking about. That's infinite lift.
No, Scoria, you're going too far.
Oh no.
I bet you could just fly off into the distance
What
now.
happens
I
if I
think that
let
the
go?
wall.
Oh, very good. Exactly what I hoped for.
Oh,
Can I recover?
What goes up must come down.
Yes, I can. Oh, that's amazing.
it's a real cartoon moment right there.
Wow.
Oh, can I go through the clouds? Okay, we're just gonna keep going. Because I'll leave the skybox, right?
I don't think
Oh,
the
that's
clouds are
not-
accessible in this
I
map.
think the
No,
invisible
there's a
wall.
skybox. There's totally a skybox. The question is, what happens when I leave it?
I don't know, but you can fly into the clouds.
Yeah, let's find
I
out.
took a
Oh,
couple
did you
videos
see
the day
that?
There you
before.
go.
Yeah, that was interesting.
Surely I'll just leave the skybox or something. Well, huh. Oh, okay, that actually went better than I expected. Huh. Wow, those are actually pretty good clouds. Nice. Alright. We're in space.
Alright, bye,
Yeah.
Scoria.
Someone asked a couple streams ago about what happens if Scoria like flies to the moon. I think this pretty efficiently answers that.
Yeah, exactly. Alright, excellent. Let me put these back down to normal length. Oh. And we do want some amount of air resistance. This also needs to go down. Flap lift is very powerful. This is my fudge factor. This is basically like how strong the wings are. So by setting it to 10,000, I'm basically saying that Scoria has like rocket thruster wings, which is fantastic. And then coupled with the other stuff, it's pretty big. All right, and I record these yet? No. Oh, whoops. These are all lift factor.
We're at about the 1.5 hour mark, just so you know, checkmate.
Oh, thank you. Yes. Unsurprisingly, I've got very much less done than I would have otherwise. But this has been very fun. Thanks for listening to me ramble. Hopefully, you know, because I can't see the Discord. Hopefully, it's not the case that I start talking about the math and half the people leave the stream immediately. Such is life.
The numbers have stayed pretty consistent.
Love you all. Thanks for attending. So I'm still trying to like make it feel very heavy. As air resistance is such a tricky number to get right, I swear. Because you want to make it you want to make it so you can't fly forever, but like you want to make it so you can fly long enough, you know. So I'm like, but like you're not going super fast. So I'm trying to find like the right balance point here. I think it's like a bit lower. Maybe this is a bit higher actually. Maybe this is right. Braking is just gonna not work for now. We'll just fall out of the sky whenever we brake. There you go. I'm gonna get the flapping and stuff working first. All right. So when I flap, velocity is still so high. Yeah, part of that is the takeoff boost. Yeah. I do like that the animation seems to roughly correspond to my intuition. It's very satisfying. Like when I'm the heavy flyer, it's so slow and plodding. Amazing. Oh, look at that. Look at that. Oh, boom. Very good. So my balance point right now is 2400. This feels okay. Actually, what do you think, Nova? This feels too fast, right? For a heavy flyer.
Probably a tad.
I feel like it's a tad too fast. I feel like it's closer though. Yeah.
Cass says the animations are incredibly smooth.
They are so good.
Thank you. I updated a lot of them. You can't really see right now because it's playing so slow, but the glide is different. It's got more movement on it, on the wings.
Yeah,
And
sorry,
also,
it's very slow.
it's okay.
I can speed it up if we want. But yes, oh my god, it looks so good.
Yay.
You can see it a little bit. You can see they're nice and flapping in the air.
Yeah, the base speed is faster than that though.
Yeah. I can up it really quick because I'm probably overestimating how fast we were going. This will show a little bit of our logic, but not too much. Where is it? Blah, blah, blah. Gliding. Oh my god, end me, honestly. Most of this is, a lot of this is going to get changed anyway, so I'm not too scared about revealing it or showing any of this. This is all animation logic. This is just to make the animations right. Where do I do play rate? There it is. So I'm dividing by 6,000. Let's just divide it by 2,000. That's good enough. I can remember what the number was. So now it should play faster, even at lower speeds. Okay, maybe that's a little fast. But
Well, it does
you can
play
see this is
faster.
what it looks like faster. It's very pretty. Bam. This might be a little bit too fast.
It's a little, the screen's a little small. God.
I'll adjust this too as I find a speed I actually like. Lower this again. Oh yeah, I need to lower this. Sorry, let me show the animation again. Sorry, I keep forgetting. I forget that, like, so for me it's really big because I have this big monitor and the stream is coming through that, but I forget that it's not how Discord renders it. All right, here's what it looks like. Oh, so pretty. Let's gain a little bit of speed. Oh, anyway. Sorry, I'll get back to programming. Animations are magical today. Hopefully I am not kicked out of the team for violating NDA by showing the animation, bro. Eve, protect me.
Neve is
I
nowhere to
forgive
be
you.
found. Oh,
He was like,
long
I was
silence.
finding with it
letting the
myself.
slip as we speak. Oh no. Okay, so definitely the takeoff boost is too high, given how fast I'm going now. Which, having really high lift feels so good for this heavy flyer. I cannot emphasize enough how right this is. Like, this really, really heavy lift. Oh, it feels so good. But I feel like the air resistance is maybe a little too low still.
Kyo Dragon says, wonder if we'll eventually be able to pull out of dives and conserve the speed so we can go really fast. You currently can.
Yes. It's just hard to pull it. Actually, I'll show it. Do that.
There's also not like a huge amount of area to show it off in this map.
Yeah, that is one downside.
If you go
Hopefully,
to
by
the-
lowering the speed of everything.
We showed that in one of our first flight clips, diving and then gliding really fast.
Oh.
If you want a bigger map, I think Ice Roads is a lot bigger than this one.
That's actually fair.
Also, change of scenery.
Yeah, change of scenery. Alright, excellent.
Kitty.
This is the other pre-made Unreal map we use for showing stuff off. And then, oh my god. Can we go any slower? Riddle me that. Why are we still so slow? Come on, just let me move. Let me be free. All right, there you go. Still slow, but good enough. Do you go underwater on this map if you land in the water?
No, you just run around on top of it.
Excellent, the best kind of water. All right. Place next to player start. I need to place a player start for extremely boring reasons.
I already put one in when I gave it to
Oh.
you, so maybe interfering.
Oh, that's great. I'll just get rid of it then. All right. Great. I'll just start in space. I approve. All right. So yeah, let me show off the dive a little bit. And oh man, we're so heavy right now. I probably need to make. This will work okay. Oh, it feels good though. All right, so I'm gonna dive, and so then I'm gonna pull out, and then you can see I can now go up because I actually have momentum. It's hard to see because of how far above the map I am. Let me actually get a little farther down before pulling out. So we go down, and then we pull out. You can see I have a decent amount of speed, but you can see my velocity is going down, and I'm slowly slowing down. And I don't have a ton of air resistance. Actually, I have zero. Why do I have 0 air resistance? Huh. I need to check that. Apparently I have 0 air resistance. Oh, I forgot. No wonder everything feels a little weird. Let me change that. I forgot. After changing it to 0 air resistance, I forgot to change it back.
I reminded you and everything, checkmate.
I'm sorry, I forgot. I'm dumb. Oh no,
good.
I've been ruined. All right, there we go. Now we have air resistance. I'm gonna blame myself on streaming. Okay, so yeah, we'll go down. We build up a little bit of air resistance, and so then I pull out, and you'll notice, oh, it feels so good. Look at that. Have a bunch of speed, and then now the reason I'm still angled up a little bit is because I have so much speed that actually by default I go up. Because I have a lot of speed that generates a lot of lift. And so now of course I've slowed down because I pulled out of that dive. So just to show the whole interaction again, because I think it's kind of cool. We're gonna gain a little bit of height here. And then we're gonna go down into a dive, pull out, oh, barely, and then I go up. I'm not pressing anything right now. So I'm just going up naturally because I have so much speed that I still have a bunch of lift, and so now I'm slowing down, of course. There we go. And I'm stable at my 2500, which is a bit fast, but hopefully that answers the question. I think it's neat. It's very satisfying. Oh, I feel so heavy right now. I love it. Okay. Yeah, the drag is still a bit low. You can also, from a technical perspective, or from a design perspective, I think this is kind of neat. So my drag goes up, and then as I'm pulling out, my drag is really high because I'm like applying all this force. Then once I kind of hit stable, my drag levels out, and this is because I'm at my critical drag or whatever. So like, what you're looking for when you're flying is kind of this drag velocity tipping point, and you kind of now the worm. The way I've programmed it is the worm will try and find it for you. So if I don't press anything, this is kind of the default. If I try and go up, I can't do anything now because I have no speed. But if I go down and then intentionally go up, I'll climb faster, but I'll lose speed very fast if I do it right. Yeah, you can see my drag shoots up and I'm kind of wobbly and stuff. This is because I'm trying to force it to go up instead of finding that natural point, which means you can like go up pretty fast, but it's also I think
You
my
have-
drag range might be a bit high. Go for it. Yeah.
You have a lot on, right?
Lods? I don't
Or like
think so.
lower setting.
Oh yeah, sorry, I'm on low
Yeah.
settings. Yes, we should probably look at what it looks like when I turn on my epic settings. I'm gonna lower effects.
I was like, oh, Scoria's claws look a little crunchy.
Yeah, sorry. Let's lower a view distance. All right, let's actually look at things being pretty with proper with full settings. Ah, yes, much
I mean,
better.
You can't tell for the most part, which is good. But
Yeah.
I just noticed that the feet were a little funny.
Yeah, they're a little crunchy. Yes. And obviously I'm not worried about performance. My computer, even on high settings, is not even hot right now because, as I mentioned, the actual physics is nothing. What I'm worried about is scalability. Now you might be interested to note that my drag actually goes down for a bit, and then goes back up, and then it's going to go down here even while I'm climbing. And the reason for that is that the balance point is actually a little above neutral. So I'm going to hit it, right about now. And then if I go down, but it's not, your maximum lift point is not the same as your minimum drag point. It's a complicated interaction. It's very cool though. Turning introduces a lot of drag, of course. Yeah, very good. This is still not quite right. Okay, so this step, this thing.
Keo Dragon
Yes.
said, I think you're thinking of terminal velocity with the critical drag.
Good point. Good question. It is actually technically a bit different, annoyingly. Basically, yes. Basically, I think that's a fair way to think about it. I am not hitting critical velocity. There's this long tail where if when you're below critical velocity where you have higher drag, but you can still keep moving. So critical velocity is when your drag roughly equals your force. So then you can't go any faster because then your drag is matching it out. There's a critical drag point where your angle, basically changing your angle will always increase your drag. Or similarly, there's another one where changing your angle always decreases your drag. I'm referring to the angle change, not the velocity change. Technically speaking. It's not it's not a very important distinction, but here it matters a weird amount. And this thing I'm saying do not touch is I think the thing I need to keep touching. So we're going to see how this goes. Let me look at my equations again. This is the variable I'm changing here.
Do
As you
not
can see,
press.
it's very intuitive.
Do not press the red button.
Yeah, immediately presses red button.
I have to run to the bathroom for a second. Make sure to regularly take the community for oil changes so they don't explode.
Okay.
All right. Sounds good. Seems legit.
I'll be back in a couple minutes.
Sounds good.
All right, everyone, let's light the server on fire.
Oh, panic! Okay, I actually really like starting in space for flight practice. I'm gonna steal this spawn point in the future. Okay. Yeah, I think this is actually I think pretty good. Yeah, changing that do not touch variable seems to be getting what I want. Oh my god, I can't believe that actually worked. So what this does, to go back to the question, because this is very much tied to the critical velocity point, which is a very interesting one, because this is essentially adjusting the critical point here, which is very, very technically specific, but I think it's giving me the effect I want. Which you can't do. In real life, you can't do this. I am totally cheating, right? That's just not how physics works. The closest thing you can do is you can change the shape of your wings, which kind of indirectly adjusts this number. So if you look at something with a different wing shape, that's actually physically what's going on. So I guess maybe the right explanation for what I'm doing right now is I'm adjusting the wing shape. We're walking on water. Yay. Oh, but now I can't get off the ground. Oh no. I don't have enough. I'm not strong enough. All right, let's try again.
I do think it would be interesting to have worms that are just so heavy that they literally cannot actually go up. They have to climb to the top of a mountain and launch
And
away.
then jump off. That would be funny. I mean, I guess we kind of had that there. I
Yeah.
should check really quick. Oh yeah, what happens if I plow into the ground right now?
I do
Ow.
have a concept for a dragon that flies that's even heavier than Scoria and doesn't have as good wings as it either. But we'll see.
I mean, from my experience, gliders are always pretty fun to try to work your brain around.
Yeah, definitely.
Oh no.
Goodbye, Scoria.
We'll miss you. My people need me. Collision in this map is a little fun.
Oh yes, it's just it's one of the Unreal maps. I think it's because it used to have a bunch of like human structure assets that I cleaned out. It was meant for it's called automotive winter map or something like that.
Yeah, I saw. Yeah,
It's meant for a little car drive by. You're not supposed to go into the water.
That makes sense.
It's huge though, even though like you don't see most of it. There's like a ton of mountains back there.
Oh
Oh,
no.
Scoria. Oh no.
Scoria. Oh no. All right. Well, I have some more debugging to do with the IK. We're just gonna pretend that didn't happen. I was gonna cut down my scalability, not making my computer sad for no reason. I always turn on medium status because you can't tell what's happening. Actually, my computer is still fine. I don't know. Unreal. I don't feel like stressing it out. My computer's had a long week. All right. Okay, this is a little low. Flap acceleration needs to be a bit higher, but I think my air resistance needs to be higher to compensate. We're gonna go with this. We're ignore the other ones for now. I feel like we're close. We're close. Okay, what's our velocity now? Oh no. Wait, what? Why do
I'm back. What's this about me not paying for heat?
You don't need to worry about it.
Yeah, it's fine.
I feel the velocity is actually really good right now, and the drag. Okay, I feel like we're going down a little too much. What do y'all think?
Yeah.
The velocity feels right, but the drag I think is a bit. I feel like the drag is maybe right, but we need to. It's so hard to pull. Okay, well.
Is Scoria 1 point times or is it half size right here?
It is 0.8, I think. It's
Okay.
actually quite big. All right, so right now it's really easy to stall. So I think the problem is that my thrust is actually a bit low, but I think the drag is actually correct. Like, it's Scoria is big. You should have a lot of drag when you're trying to do stuff. I feel like that kind of matches my intuition. Oh
Yeah.
no! All right. So we're gonna. So air
Everything was
resistance.
gliding,
I think
I guess.
we're about correct. Yeah, but even when so my idea is, okay, maybe I actually do need to cut down this gliding. Yeah, if I cut down this gliding a bit more, I feel like this might actually match. And then we need to bump up lift a little bit more. And even if you don't know exact numbers, feel free to suggest like higher or lower for a specific thing or whatever. Hopefully I'm explaining enough what I'm trying to do here.
Well, Andrew suggested upping the scale from 0.8 to 8 and seeing how the flight behaves then.
All right, excellent. I'm a fan. Let's do it.
Oh no.
I'm not sure. I might have to adjust how far the camera can zoom out. So give me a sec. 8. And let's just assume that I need to adjust this camera a little bit. TLS FUD, camera arm, there we go. No, camera arm. Target arm length. Wait, no, this is wrong. It's where is it? Oh my god, I haven't adjusted the camera forever. There it is, max cam distance. There we go. All right. Still not enough.
You could just load it.
We also need to make this more like 500. I'm never gonna be able to see scoring otherwise. All right, there we go. Oh no, it literally Unreal's preventing me from scrolling out farther.
Wow. That's just a blimp.
Well, flight still works, so that's good.
I mean, sort of. It's really hard to control.
It looks like one of those parade floats, I think. Parade balloons.
Oh no. Okay.
Disastrous.
Amazing. I think you mean. All right.
Yep.
We can actually fly with this really quick. Let me just adjust this up a little more so it's not a misery. Because I think it'd be funny to actually fly around as a blimp. I just need to.
Next, you could do like 0.08 size. No,
Ooh,
that'd
that's
actually be
true.
too big. 0.008.
All right, let's do it.
Just become an ant.
And actually fly. I don't know where I'm going. I can only use the velocity to kind of gauge anything.
Seagull says you get to play as Megascoria after beating the game.
So if I go into a dive, what happens? Oh, I can actually recover. Very good. Very good.
Gigantamax, is that how you pronounce it?
Yeah, exactly.
Gen 8. I
Alright.
think it was Gen 8 mechanic or something. I don't know. I stopped playing after X and Y.
All right,
It is
Mesh.
Gen 8
Let's
banana.
go back to normal.
We gotta make a tiny Scoria. All right.
His baby.
Oh, where
Where
are
is
you?
it?
I think it
Where
doesn't
is it?
render. Let's try a
Oh.
little bigger. I think it's less than a pixel from from where the camera is. Oh, let me fix the camera too while I'm at it. Because max cam distance needs to be like it's 400 or whatever I picked. It's 4,000. It might have been 4,000. Maybe that's why I couldn't zoom out more. Whatever. Great.
Tiny Scorias are related to house hippos.
I see. I'm just dumb.
Oh, goodness.
There he goes.
So quick.
So we're changing our growth model again to make it so that every tier 4 just starts like this.
Oh my god, you run so fast too because it's not relative to size. Oh no.
It's a very fast flea you've got there.
Oh my god, it's terrifying. I'm just gonna hide in the road.
Oh.
Alright, fantastic.
That's how they get you.
Sneaky scoring. I think points. I'm gonna go a little bigger, I think, even than I had before. I might also switch back to the tree map so I can see like how I feel relative to the tree, if that's okay. Also, we haven't. I would just like to point out we never got to spin the wheel, because Unreal has been so stable. I protected it too much. I was too careful.
If
with my
we
tricks.
if we have no crashes, maybe we'll do like one wheel round at the end, but that's it.
Yeah. Okay, maybe you're a little too heavy right now. It does feel heavy though, so that's something. How do you think the speed looks? I feel like it might be even a little slow.
I think
run faster than I fly.
as long as it doesn't feel bad, the slower is better. Especially because we're gonna have fast worms and map size.
That makes sense. But I mean, in terms of like relative to the trees, I mean, whatever. We can always what you can always do is just like multiply everything by 2 or whatever. Like it's fine.
That's
but
true.
like, do you think this is relative to the trees? Do you think this is like?
I think that's still pretty good. Yeah.
Okay. All right. Then I will adjust it so I can actually get off the ground. I think I know how to do it, and then I'm going to record it. I think I'm going to call it done. I think we successfully got a heavy flyer. I was hoping to get to an agile flyer, but this. I'm gonna blame the audience for being interesting.
Well, we have a little time to do some agile flyer if you want.
All right. I'll mess around with it. I'm gonna mark this as done and then do some fiddling on my own pretty soon here. I just want to get this initially recorded. Yeah, actually, I'll finish this later because I still need to finish breaking and stuff. But
thank
I
you,
do want to
F-Zero.
mess around with agile. Are people leaving?
Just F-Zero is.
Okay. Yes, thank you for joining. All right, so I'm gonna call this heavy flyer because I think this is about right. And we only care about this.
My mic's not picking up my fan, is it?
I don't think so.
Is it picking up my fan?
No.
My computer decided that the heavy graphics mode on Icewind Road was a little too much.
Oh no.
Finally.
Guppy said, now I wonder how small the team is willing to make a worm Osh to be a tiny menace to society. Several of us also want that, but we'll have to see how small they can get.
without being like completely imbalanced, I guess.
Yeah. I don't think they should be smaller than Lindwyrm. Like a max size Lindwyrm. We'll see though.
There's also the whole thing of like, what happens if you're a tier 3 dragon and you finally get that much weighted tier 4 evolution and you're just like half the size or smaller? Like,
Yeah.
That would be amazing, though. Oh my god!
I
You like
know
become your
it
final
would, but
ultimate
it's something
form,
you
and
have
you're
to
just
think about.
small, so tiny.
I mean, the whole point of like the evolution system is like adapting to your environment. So you just
It's
adapt
true.
to be smaller.
I know it'll be so good, but it's also it's so good.
Oh my god, I'm so.
There's some
Oh.
caterpillars that are like bigger than their moth or butterfly form, right? I feel like that should be a thing.
I'm
There's some huge
not
caterpillars,
even
that's for sure.
talking from that standpoint. I'm talking about like what if people didn't know beforehand, would they be disappointed that they're now half the size of their awesome dragon?
If I went into your Pokemon is evolving and out came like a little tiny flea, I'd be so excited. That is my other
I've
comment.
wanted that for 9 generations now, and it hasn't happened.
There you go.
Madness.
Kehoe said, can we spin the wheel for Discord crashes? No, then we would be only doing the wheel.
When Unreal is more stable than Discord. Oh, I'm shocked I have not crashed yet. Very lucky. All right, so now I'm going to be trying for something more agile, which I think the air resistance, I actually want to keep air resistance similar. My guess is that air resistance while gliding should be higher. The sprint value, should be lower because
so
sprint better.
Everyone, now we're going to pretend that Scoria is supposed to be an agile flyer, and
Yes,
we're going to
absolutely.
figure out values related to that.
Yes, thank you for explaining that. And the way I'm going to make this look kind of correct, I was originally looking to get a new model set up, but it turns out setting up models with animations and stuff takes effort, and I am lazy. So instead, we're just going to make Scoria small, and we're going to pretend that now it is small and agile.
Show like a little video clip or a preview of it later.
Yeah. No, we definitely have other models. I was just, and they're even like loaded in and everything. I just didn't have time today because I was too busy sleeping. All right. So yeah, what was I doing? Oh yeah, movement component, TLS movement, flight. Okay, so a more agile worm needs to should shape its wings so it has a slightly higher critical lift angle. This makes sense to me, and maybe even higher. This is high, so most planes have a lift angle of like 25 or something. So yeah, we want to be more agile than a plane, I think, in terms of up and down. So yeah, let's go like 40. I'm just gonna like roughly estimate this. Birds are actually quite agile. I might be underestimating this, but we'll leave that for now. We want the flap lift to be quite high. We want the acceleration probably actually not to be super high, probably a bit lower actually. I'm just like estimating based on what I think. Importantly, the wing lift needs to be quite a bit lower. This is, I think, going to be the key to making it feel very, very swift. Ironically, but. And then, of course, our max roll should be like 40, 60. Initial estimate. Roll speed should be like 90. What I'm imagining in my head is something resembles like a sparrow or like a, these pretty small, not like a hummingbird or something, but something that can like dart around more. Or like a, I don't know, 11 darter. Max wing pitch should be like, max RBS should be like 30 probably. That's going to be a bit too high. Min dive pitch should be lower. Can't dive as hard. Needs to be higher. 50. I don't know what those are yet. All right, this is my first estimate. This angle drag resistance should be higher, I think. Not sure. This one I actually realize I may actually want to change it. Yeah, there you go. Higher, more agile climbing and turning. There
Why
you go. That must
did
be good to
past
change.
checkmate even write that?
This one is the only the reason. Yeah, it's complicated. I did it for now. It was a warning to myself that this is danger zone because I have to sit here and stare at these equations. But I think this is right because it's alpha over that. Yeah. Pass checkmate is stupid though. We don't like them. Okay. I'm not sure on that one. All right, let's go. First attempt. Are we small? Okay, we're small. We're small Scoria. Let's see. These big trees.
Smolia.
Yes, we can run very fast because I haven't adjusted. Oh my god, we're
Moria.
walking so fast. I think we're also sliding. I don't know. Such is life. All right. All right. Okay. We might.
You may be a little too agile.
It would seem that way. Let's see. Where's my? Yeah, my lift is too low. That makes sense. And also my flapping lift needs to be higher. 3,000. But yeah, lift should be more like that. Not 6,000. And I might even need to bump the heavy one up. I'm not sure it's enough, but let's try 4,000. I won't explain exactly the relationship between lift and gravity, but having lift be roughly equal to gravity sounds reasonable. Yeah, there we go. We're feeling a little. Yeah, we're not climbing as much as I would have liked here, as quickly as I would have liked, but.
How big are you?
0.5.
0.5.
And let me. Where's my player start?
I think when I tested for 11 values, it was like, what, 0.3 or something? 0.2?
We start off in space so I can iterate faster.
Oh, I missed it earlier, but Kyo Dragon asked earlier if changing the gravity would break everything.
Good question. You cannot change gravity right now. I stop you from doing so because yes, it would break everything right now. So I cannot show you how it would break everything, but basically some calculations are correct and some are not. That's the short of it. Oh, yeah, I need to be even higher because my reaction times are slow apparently.
Vibrating trees.
What are you? Right. Oh no, I deleted the right one. I see. You are a lie. You must perish for your lies. There we go. Great. All right, excellent. Yeah, lift is not enough. Let's crank it up. Apparently increasing the air. Well, I could decrease air resistance instead for now. Yeah, let's just crank up lift for now. It's like we're seeing if we can get this working in less time. I think I want to decrease both, but. And I'm still just crashing. I'm not generating enough lift for my speed. What's my speed at? Well, high. What are you? What is that? Oh, that's important. That's why there's a sun. I see. All right. Yeah. So yeah, but my velocity is quite low, which is good because we want to go slow. But unfortunately, that means I also cannot actually stop myself from crashing to the ground at the moment because I'm not moving fast enough. All right. So yeah, let's just continue cranking this up.
Kyo Dragon says this is reminding me of that scene in How to Train Your Dragon where Toothless is trying to fly but can't get up before crashing.
Valid.
Have you tried fixing the tail membrane, checkmate?
I have not tried that yet. I'm lame. Okay. This kind of works for a little wobbly. That's fine. Let's
Time to
correct
learn
that really quick.
blacksmithing.
Whoa. Whoa. Okay. All right. We are Okay, drag is definitely too high. Wow, okay. We're very agile at crashing into the ground, so that appears to be how life is going at the moment. Oh, man. It feels kind of cool, though. Okay, so we
Claw.
definitely need to crank this down. This does not feel right. Let's just go much lower. I don't care what those are. And they may not be consistent between worms. I make no guarantee that like every worm will have the same air resistance based on its wing shape or whatever. All right. Oh yeah. Oh, that's kind of cool. That's awesome.
It looks like
Yep,
it's spinning in
it's
place.
very bird.
Yeah, I feel like I might have cranked it down a bit too much because now I can just kind of fly slowly forever. But it's pretty funny. I do feel very agile though, so that's good. I do feel like I should be crashing here though. What do you all think? Feels a little bit, like a little bit much.
It looks kind of like you're flying backwards.
Fair.
I would agree. Probably shouldn't be able to do that.
Yeah. Whoa.
Andrew says maybe you should stall there.
Yeah, it's. You should definitely stall. Okay, all right. My solution is going to be kind of a non-satisfying one. By the way, if any, just for fun, I've never tried this. Let's see what happens. I've never done this. I assume that you just fall out of the air if you do this. If I just crank up max roll to the max. Okay, yeah, very good.
Twirl the scoria like
my.
spaghetti.
What if I crank it all the way up? I've never done this. Okay, I can't do 180. It'll probably just crash under. No reason to mess around with that. All right, let's try this. I've never tried going upside down, but in theory, you should just go straight to the ground. Let's see if it works.
Poor scoria.
Working as intended.
Amazing.
This is why we don't have non-animated loops, by the way. If you try and actually do the physics for them, you get. Oh my god, you can actually.
Oh, I didn't see that. What happened?
Almost did like an actual flip.
I tried really hard. If I just like span space to like give myself velocity, we can like.
Oh, oh, oh.
All right, that's a bit much. All right, I feel like okay, so I feel like having a roll greater than like 40, it just never feels right because the problem is okay. My theory is that if your roll is that large, you're moving right faster than you're moving forward. I think it just feels wrong, even if it's like physically accurate. Because yeah, I don't think that feels right. So let's just try this one really quick. I'm gonna just pick a number and let's cut this down a tiny bit because I think it is a bit high now. Well, we lowered air resistance, so we can cut this down a lot. All right. Oh no. I think there's another spawn point somewhere, and I'm too lazy to find it. All right, so we are stable. It's a good start. Okay. So we're gonna bounce a lot when I use W. I'm just not gonna use it for now. It's a different fix. Okay. Let's try flying through some trees. I feel like this is closer to what we want. The air resistance might be a little low, but oh, that felt kind of cool. And my pitch speed is a little low. Oh, I keep crashing into things because I can't actually. I'm not actually good at flying. Is the core issue here. Climbing, I think, is a little not great at the moment, but otherwise, this feels pretty good. This is actually not a terrible starting point, I think, for very agile. Oh, okay. Apparently diving is a little intense right now. I know why. I'm an idiot.
Back you, Dragon. Thank you for coming.
See you. And turning, in terms of turning, do you think this feels? I feel like this looks pretty good. The amount that I'm going up and down seems hard to control, but like in terms of agility, I think we're on this. I think this is the right track at least. Whoa. What do you all think?
It's so hard to tell with the huge wings.
It's true.
Andrew
makes
says
Scoria
seems
even
good,
smaller.
question mark.
And it's true. It is a little hard without the animations. Wow, turns are so fast though. That's crazy. So it's really interesting because when you turn, it feels very very odd because you immediately. So you know, if you're flying normally, you just when you turn, you immediately kind of pitch down and then pitch up because you like gain speed and then turn that into control. I am turning a little. Oh, that feels weird. Wow.
I do like the circling.
Yeah, the circling feels good. I feel like it's a little. It's a little too easy. I feel like I should be losing more height while doing this, but. Eh. Oh, I do have tuck wings, by the way, so I can try tucking wings while maneuvering here if I.
Oh, is that it again?
Yeah, it works as intended. It doesn't look like it works as intended.
Ah, nice.
It is actually physically doing what it is supposed to do. It just the animation, the way I hooked it up is a little janky. But yeah, you can use it like you're flying forward. You can use it to kind of quickly adjust height. Kind of. The problem is it doesn't pull out of it very effectively at the moment.
Oh, I like it.
Thank you. The way tucking works, you can actually see exactly how it works if you look in the upper left. Here's my lift, and then I tuck wings. It just goes to basically 0 because I'm now a rock. So that's it. That's really all of how it works. Great. Wow. All right, so I can keep fiddling, but I feel like that's a reasonable stopping point because it's like a very different thing, and it's been 2 hours, and I've been talking about a lot of math. Are there any other questions or things people brought up? Are there any other things people want to see?
Yeah, does anyone else have anything last minute? Want to
I
request or
feel like
ask?
energy is just, it's a good spot to end.
Andrew says he wants to see Scoria turn on a dime, like really have no turning radius. I mean, that's pretty much just making him a tank. We've had that before, but
Oh, like on the ground? In the air, I
he
think
wants
I
it in
can't do any
flight.
better than Oh man, I don't think I can do any better than I already have because you can't, if you stop moving, you just plummet to the earth. So I don't think I can do better than having a really high roll, which I can show again. I think this is about the closest I can get to that. Let's try really. Oh yeah, the problem is you lose so much height when you try and turn quickly, which makes sense, but like I can't. Yeah. Unfortunately, physics is disagreeing with this this approach. This Okay, this is probably the closest I can get. I'm amazed I am not plummeting to the ground right now.
And Andrew requests 8/8/0.8 scale scoria.
That is a fair thing to do. I admit I never tried anything except one of them being small. Where is it? Mesh. Transform. There we are. So 8/8/0.8. I have no idea. I assume this will be flat scoria, right?
Message in the voice chat. Oh shit! Oh, oh, you're flat. Oh, oh my goodness.
It's paper scoria.
Oh god.
Hello.
That seems normal.
You look
Alright,
like
we
a
can-
jet plane. Or like the really, really flat ones.
Oh my god.
And yeah, thank you for your message, Grape. Okay, now enter one 0.8/8/8.
Alright. Okay. Let's see how that goes. I assume we'll now be
Oh, squinch.
when you walk behind
That's so weirdly almost 2D.
Yeah, if you change the angle you're looking at it, it's different. Oh, I think I did this once. I took a video.
Oh,
This
there's
is
that new
our,
Paper Mario game. You got the
yeah.
crossover.
This does feel very Paper Mario-y. That's great. Is that how they did it? I believe it, honestly.
Then Andrew also wanted
No.
8/0.8/8.
Make very thin scoria.
I didn't
Welcome
hear it.
back,
What was it?
Dragon.
What was its name?
Dragon, we pretty much finished the flight stuff, so now we're just doing silly things before we leave.
I heard. I don't know what I heard, but maybe it's this. Beanpole scoria.
Oh,
Huh.
Now scoria is the pencil.
can't even tell what that is. What? What kind of flight mechanism is this? Pulley system? Are you just dragging
Looks
yourself
like
using the moon?
windmill. It's
As you can
rotating.
see, we put a lot of thought into realistic wing shapes for our creature. Body shapes too.
Oh, amazing! All right, I didn't actually hear what that was. I'm gonna assume that that's what was intended. But what happens if it's no, we already counted it. What happens if it's exactly one? I'm not actually sure if it's exactly one of the X-Flaws. Oh yeah, excellent.
Oh, hello.
Long scoria.
Torpedo.
Andrew says SR71 scoria.
Looks like it's trying to drag itself along the ground. Oh, here we are. Oh. Here's some flatland scoria.
I guess. I mean, this is entirely just matrix math, right? Oh no, it's
so loopy.
so weird. It's so weird.
Oh no.
For implementing
What happened to the other
episodes
one?
early, I see.
I like how the wings are like offset because of this, because it's dragged along the end. Like right around here, it looks almost like is kind of correct, but like amazing.
Do we want to do one round of the wheel before we leave? I know
And stop sharing.
Gala can't because her computer would explode.
Oh, it's just me then.
Mystic might want to.
Oh.
Sure. you'll be able to see how terrible my drawing is.
Just give me a second to grab the first wheel.
I did successfully stop sharing my stream, right? So I can browse my art scammers that messaged me in peace.
Oh, good.
Yeah. Not from our Discord. It's all good.
At least there's that.
It's one of my other dragon Discords. Oh wait, no, I'm not a traitor. You're a traitor.
Oh. Are you gonna draw too, Nate?
Okay, so the creature being drawn will be Scoria. I don't know. I could. Well, I don't know. I don't know if I can record everyone else's streams while drawing myself. I'll have to see.
I can't record mine anyway because I have to use a different device. Can't draw on computer.
Are you going to be
Oh,
streaming yours, or are you posting it after?
I'll post it after. I'd have to figure out how to stream on the other device.
I guess I could.
Oh wow, I'm seeing the list
Oh,
of people
no.
that
Oh,
I'm
good.
no longer.
You know, I should have skipped that one for this one. Do you want to reroll?
I
I
mean,
can
I
see how many people are on the
could,
stream.
but
Okay.
Thanks everyone for hanging
Okay,
out.
so modifier
don't
1 is
forget.
eyes closed.
eyes closed. Okay.
Oh
boy.
but there's gonna be a second modifier. Will it paste?
Oh, a second modifier? Oh no.
We gotta get more.
$30 seconds.
I think that's.
Oh no.
I think that's almost what happened last time. Okay, so are you gonna be able to to try it with your eyes closed in 30
Interesting.
seconds?
Sure.
Okay. Yeah, I'm not gonna participate because I want to make sure that I'm actually showing this on the screen. Let me get the stopwatch. Okay, are both of you ready?
Yeah.
I'm ready.
So Nova will be streaming hers, but Mystic will just post hers afterwards. Okay. You can start at 1. Make sure you close your eyes. 3, 2, 1.
I already know this is gonna be interesting. Oh.
About 5 more seconds to go.
I don't know where the belly is. The chest. Where is it?
And time's up.
Completely.
Oh, it's beautiful.
Oh no.
Nova, yours was going pretty well until the leg.
Oh no.
Submit.
I'm surprised the neck spikes ended up in that spot.
Yeah.
I kind of cheated on this one. Oh, wait. Why didn't it? I didn't upload. Hold on.
He doesn't remember.
Nova, are you cheating and
Take a
drawing a redemption?
screenshot.
What? No, I'm just doodling something. And it's not for redemption. I just wanted to draw Scoria now. But I'm doing it for memory because
Drawing from memory,
There
this
we
still looks
go.
closer to Scoria than anything I could draw, like copying from a reference.
I did cheat a little bit on this one because it's only 30 seconds. Went with Pillar Scoria.
Looks like
Oh, it's Pillar
trees.
Scoria.
Those trees came out a lot better
I
than I
guess
thought they would, though.
I guess Pillar Scoria is easy to draw.
Gloria. Oh my god. Can we have a Pillar Scoria in game? And there's like an artifact that just like spawns Pillar Scoria.
But then we would have to be like, rated M because it's too scary.
Wow.
It's truly horrifying.
Now I feel like we can't leave because I'm invested in this second Scoria Nova's drawing.
I am invested too. This is amazing.
I remember.
So for context, I was making some sample texture things to like show off how something would look in game, and I was trying to draw Scoria from like I took a screenshot and then took it, and it looks like way worse than this. I'm so impressed right now. Like this actually looks like anyway, whatever. I don't understand.
Nova, can you put a bow around his neck?
Like a bow in the front or in the back?
It doesn't matter.
I know a lot of people listening are artists, and I am demonstrating my lack of art ability, but it's still so cool to me.
Neck is too.
What a polite guy.
I think the plates went up, right? Like that. And there's spikes on the side. Sketchy sketch.
Guppies, we'll also upload the VOD, so people will be able to look at the VOD and take screenshots from there.
This also had plating. Something like that. Plating on the hand as well. This is a thumb. I think it was actually more like match the way that the wing goes. The wing is so huge, it's just going to stretch off the canvas.
Can the audience name this specific Scoria?
Sure, why not?
It's not a very creative name, Andrew.
There we go. That's a more calm, chillin' Scoria.
No, I want the audience to come up with a name for him.
Remember how the plates went here? I think there's like something like that actually. It's a lot thicker at the piece.
Grape says Faboria, and Dragon says Freckles.
Freckles Friboria. It's like a surname.
Yeah. Andrew says Skragnar, protector of the 14 scrolls, defender of the Obsidian Gates.
With a cute little bow.
Sequel says Dee Dee.
There's like a bunch of there's like a scale pattern right here. I don't want to draw all of it, so yeah.
Angrape says Cece.
Probably too many plates here, huh? I don't remember how exactly, or how many there were exactly. This connects to the base of the tail. The tail has like it always has this curve like this at the end. But I guess I can't really see it right here.
Andrew says
I remember.
Roger in demonic text, and Nerdy Nobody says David Bowie.
They're all good names. Like this. Priscilla. Scoria is so long. I had plates here too, right? Like flat plates, and then also on the fingers. This was like, actually, they were kind of connected, weren't they? Skin. There we go. There's that chillin' Scoria.
Yay.
I'm not coloring this thing.
Print it out and color it in with watercolor paint.
Interesting.
You're saving this, right? I want.
Sure. I mean,
I'll take a screenshot.
I sent it in the.
Okay. All right.
Thank you.
Okay, I think we're ready to leave. Nobody has any last minute questions or anything?
Thanks again, everyone, for
Yes.
joining.
Have a nice day, everyone.
Thank you for coming, everybody. Hopefully you didn't mind the number vomit.
And thanks for listening and suggesting some silly numbers. I approve. Numbers. Please.
I see Grape is typing. Thank you for best game, Grape. And thank you, Atomics. I hope you didn't disturb the zoo animals on our behalf. And just so everyone knows, we'll be uploading a VOD of this, so if you want to go back or if you missed it, you can go watch it. Okay, thank you for coming, everybody. Bye.
Thanks for coming. Bye.
Thank you.